friends, myself Charan. Today in this video, I would like to share the topic regarding a pair of linear equations in two variables. Recently, we had completed the two chapters of 10th CBSE mathematics textbook. They are chapter 1, the real numbers, and chapter 2, the polynomials. The complete videos of these two chapters are available in my YouTube channel playlist. So please kindly watch, share and subscribe to my YouTube channel, that is Maths PPT YouTube channel. Okay. I am new to this teaching field, so if you want to give any suggestions to me, please mention your suggestion in my comments box so that it can help in improving my career in this YouTube channel. Thank you very much. Chapter 3, Pair of linear equations in two variables. Okay. From the chapter 2 polynomials, we have learned that the highest power of variable present in an equation is called the degree of an equation. So, based on the degree of an equation, the polynomials are classified into mainly three types. They are, if degree is equal to 1, then we call it as a linear polynomial. If degree is equal to 2, then we call it as a quadratic polynomial. If degree is equal to 3, then we call it as a cubic polynomial. So, if you want to make a linear equation, then we have to equate linear polynomial to 0. That is, a linear equation can be formed by equating a linear polynomial to 0. Okay. In the second chapter, we have seen that all these polynomials are represented only in one variable. So, that is, all the terms containing in the polynomial are having a coefficients of the same variable. But here, in chapter 3, these are linear equations in two variables. That is, the equation is made up of two variables that may be either x or y or z or a or b and so on. So, here in this chapter, the title itself says that it mainly deals with the pair of linear equations in two variables. That is, in this chapter 3, we mainly focus on pair of linear equations. That is, two equations are given, and from the two equations we want to solve by using some mathematical operations, and we want to find the value of these variables x and y. Okay. Now, coming to its introduction, an equation which can be put in the form of ax plus by plus c is equal to 0, where a, b, c are real numbers and a and b are not both 0, is called a linear equation in two variables x and y. That is, here what they are saying, the general equation. The general equation of a linear equation in two variables is ax plus by plus c. Here we can clearly observe that the highest power of these two variables, that is, the highest power of x is 1 and the highest power of y is 1. Why? Because we all know that if it becomes a linear equation, then the degree must be 1. So here, even though the equation having two variables x and y, the highest powers of these two variables are not exceeding 1. Okay. Now, and the second point they are mentioning is, here a, b, c are real numbers and a and b values never be equal to 0. Why? Because if a value or b value anything equates to 0, then the total expression be converted into a linear equation with one variable. But here we are dealing with a linear equation in two variables, so that these two values a, b are not equal to 0. C may be equal to 0 or either may not be equal to 0 based upon the given equations, but a and b values are not equal to 0. Okay. We often denote the condition a and b are not both zeros by a squared plus b squared not equal to 0. So we can represent it in the mathematical form as a square plus b square not equal to 0. Okay. You have already studied that a solution of such an equation is a pair of values, one for x and another for y, which makes the two sides of the equation equal. So in this chapter, what you have to do, mainly we may focus on the solving of these two equations by using some mathematical operations, and we want to find the values of the two variables, that is x and y. For example, let us substitute x is equal to 1 and y is equal to 1 in the left hand side LHS of the equation. So let us take an equation 2x plus 3y is equal to 5. If you substitute the values of x is equal to 1 and y is equal to 1, then we can clearly say that the resultant becoming 5, that is, which is equal to RHS. So if you want to check whether the given equations are balanced or not, we want to find LHS individually and we want to find RHS individually, and we have to equate LHS and RHS. If you find LHS and RHS values are same, then we can say that the equation is balanced. Okay. So therefore, x is equal to 1 and y is equal to 1 is a solution of the equation 2x plus 3y is equal to 5. Okay. Now, let us substitute x is equal to 1 and y is equal to 7 in the same equation, that is 2x plus 3y is equal to 5. Then, if substitute x is equal to 1 and y is equal to 7, we are getting 23 as a result in LHS. And we can clearly see that 5 is the value that is present in the RHS. So 23 is not equal to 5. Then we can clearly say that the equation is not balanced, and therefore x is equal to 1 and y is equal to 7 is not a solution of the given equation. Okay. So here LHS means left hand side and RHS means right hand side. So for an equation, equal to is made as a center for an equation, and the left side, the left part that is present in the equation is considered as LHS, and the right part present to the equal to symbol is considered as RHS. So here when we calculate it becoming in 23, which is not equal to 5, which is present in the RHS. Okay. So hence x is equal to 1 and y is equal to 7 is not a solution of the equation. Geometrically, what does this mean? It means if you represent this equation in the graph, we can clearly see that the point 1, 1, which we take in order to substitute in the equation in the previous 1, 1 lies on the line representing the equation 2x plus 3y is equal to 5, and the point 1, 7 does not lie on it. So every solution of the equation is a point on the line representing it. Okay. Now, in fact, this is true for any linear equation. That is, each solution x comma y of a linear equation in two variables ax plus by plus c is equal to 0 corresponds to a point on the line representing the equation and vice versa. So here in these 2 points, what they are saying, if for what the values of x and y, the equation getting balanced, that indicates geometrically the point x comma y value is a point on the given line representing the equation. And if the values what we have taken in the place of x and y are not balancing the given equation, then it can clearly say that that point is not lies on the given equation. Okay. The general form for a pair of linear equation in two variables x and y is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1, b1, c1 and a2, b2, c2 are all real numbers, and a1 square plus b1 square not equal to 0 and a2 square plus b2 square not equal to 0. Okay. You also studied that the given two lines in a plane, only one of the following three possibilities can happen. That is, if you point point or frame a graphical representation for these two equations, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Graphically, we can clearly say that there are only three possible conditions that can happen. They are: 1. The two lines will intersect at each point, or the two lines will not intersect, that is they are parallel, or the third condition, the two lines will be coincident. See what they are saying. If the two general pair of linear equations, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, when these both lines are represented in the same graph, then there are three possible conditions can happen. One is the two lines will intersect at one point, and the second one, the two lines will not intersect, that is they are becoming parallel, or the third condition, the two lines will be coincident. Okay, we will see some other examples